Okay, so let me explain to you today the analysis of pile using EUROCODE 7. So specifically, we are going to analyze the pile use from the soil test results. There's other one using the actual load test results. Here, we're going to take the results coming from the soil testing. So you see the characteristic resistance you have here. Wait. Okay, the characteristic resistance you have RCK, or the resistance of the pile, which is a combination of at the base and then the shaft. We're going to take the mean for, let us say, for all the pile the soil test results for different let's say boreholes. Okay, and then we're going to divide it with these correlation factors, which has specific values in the next slide. And then here the resistance, which will give us the minimum value. Okay, and then divide it by this correlation factor. So again, this one stands for the base resistance, and then S for the shaft. So these are the factors that would dependent on the number of test profiles. So like for example 3 boreholes for piles, or 4 or 5. So we're going, if it's 4, we're going to use this one. Alright, now for our design resistance, take note that this resistance is going to be compared to the design actions. Again, as we say, design action has to be smaller than the resistance for it to be safe. So your resistance could be a value of the total resistance, which include the base of the shaft, and then with this factor y lambda t, and then specifically there could also be for the base, and then for the factor for the base, and then for the shaft resistance, and then the factor of the shaft resistance. So the values are given also. Okay, I'll show you to you later. Okay, so for example, you have here 10 meter long, 0.7 meter diameter. This is a CFA pile, because we have to check that every type of pile has its corresponding value for the factor. Okay, so for example, these are the boreholes 1, 2, 3, 4. You have here the borehole 1, this is the undrained shear strength 65 at the shaft, and this one is the base. And then for 2, 62, and then 79 for the base. This 70 for borehole 3 at the shaft, and then 96 for the base, and so on and so forth. Okay, so the pile will carry a permanent axial load, so VG, which is 500 kilonewton, or dead load, which include already the self weight. And then you have also here the applied transient, the variable coming from the structure or maybe the building, has 150 kilonewton. Now we're going to check the bearing resistance with reference to geolimit state using design approach 1. Take note that design approach 1 has 2 combinations. Alright, so NZ is equal to 9, and then the alpha is equal to 0.7. So as we say that the diameter is 0.7, then we can compute the area of the base, or just the section of the pile. Now take note that this part here is the base, and this one is the shaft. Okay, you see here, these are the values that you obtain from CU from the first borehole. At the shaft, no, I should say at the base, it's bigger than the shaft. This one is the shaft. So this pi dl is the area of the shaft, okay, or the sides, and then this one is the factor, which is 0.7. So you have here L is 10, diameter 10 is the length of, or the depth of the pile. So this is the total resistance or bearing strength, ultimate bearing capacity for borehole 1, and then for borehole 2, borehole 3, borehole 4. You see it changes only with its undrained strength. Here 6. Okay, this one is at the base, and this one is at the shaft, which is already given here. Okay, it's coming from the test results in the laboratory. So the mean that you will have, summing of those four, mean or just the average, sum up and then divide by 4, then you have here the value. And then the mean or the minimum, you see the minimum is at the location of the borehole 2. Okay, that is on borehole 2. We need this one. Alright, as we are going to calculate this resistance. Okay, this is the table. Now we see we have 4 value of our piles, or test profiles I should say. This one is for the mean. Okay, you have here the mean, which is we calculate the 1355 or 1355 divided by 1.31. This will give us the resistance. And then how about for the minimum? It's 1228. Okay, divide 1.2, which is this one. So we have this value. Okay, obviously we are having this value. This one will govern, which is a lower value of your resistance. That is for these choices, because we need to have a safe value to come up with a characteristic compressive resistance should be the lower value. And take note that this 1023 is coming from this 1228, which is coming from borehole 2. Borehole 2 has these characteristics, okay, because we need it to specifically calculate what would be the resistance at the base and at the shaft. Okay, so at the base you have this formula. Okay, what is this? 9 NC. Okay, this is N C, the untrained strength of the base, and this one is the area of the base divided by 1.2. okay, because this is for the minimum value. Okay, if we are considering this one, it should be here, but take note that we will arrive the safest value using this smallest value, which is coming from borehole number 2. This is at the base, and at the shaft you have pi. This is diameter, this is L, and this is alpha, and this one is undrained strength at the shaft, which is this one. Okay, so we have this value. So we have now this specific characteristic base resistance at the base and at the shaft, because we need to get the design resistance now, which we are going to compare in the design actions using first combination. Take note that the first combination we need R1. This one is for design actions. Here we need R1. So R1, we have this value. We can use these values because we are the type of our pile is safe A. For the base 1.1, for the shaft is 1. So base is 1.1, shaft is 1. Where did we get this one? This is the value of your value of resistance at the base and at the shaft, which is calculated already earlier. Okay, so therefore we have this 1002. Alright, this 1002 is to be compared with design actions. Okay, the design actions, we have A1. Take note, what is A1 again? This is our A1. Okay, for permanent, okay, the factor is 1.35. For variable is 1.5. That's why you have here 1.35 and 1.5. This is the load, permanent load coming from the building or the structure, and this is the transient or the variable, or just like the live load. So take note, 900 is smaller than 1002, meaning this is safe. In other words, if you are going to calculate the over design factor, you have 1.11. okay, this one is the resistance and this one is the design actions. This is for combination 1. Now how about for combination 2? Combination 2, we are going to use R4, and for R4 we use these values. Again, we calculated already earlier these values. Okay, so base is 1.45 here, and then shaft is 1.3. so we have this value. Alright, now how about for the design action? Okay, design action, which is intended for combination 2, A2, we have this one, 1 and 1.3. so you have here 1, 1.3. 1.3 is for the variable, 1 is for the permanent. These are the loads given initially, which you take it from your building. So again, here you see this is less than 769. Where is it? 769 is the resistance. So you have 1.11. Let us compare 1.11 for combination 2. How about for combination? It's the same. So either way, whether you are going to use the combination or combination 2, will still give you the safe value. So that's all for this pile combination, pile analysis using EUROCODE 7.